Welcome back, ladies and gentlemen, to your favorite online class, AP Statistics. Today, we're going to cover the last lesson of Chapter 4 in our book. The topic is relations in categorical data. Chapter 3 and 4, we have been looking at bivariant data, but we've been looking at quantitative bivariant data. So scatter plots are appropriate, and then we look for relationships, and we potentially do some regression and do all that fun stuff. Well, what happens if I have categorical data? Now all of a sudden, scatter plots and regression and correlation no longer make sense. Hopefully everyone got those questions right on the Chapter 3 test when we asked about, does correlation make sense in certain settings? And you would say, no, those are categorical. Okay, so here's what we can do with categorical variables. First thing we would do is make what we call a two-way table. So here's a two-way table from data from the Titanic, right? Hopefully you guys have heard of the Titanic, right? Big boat, it sank. Leonardo DiCaprio was on it. Kate Winslet, I think, was there too. So anyway, you can see that this is categorical, right? I have row variables, I have column variables, but my row variables are survived or died. Those are categories. My column variables, men, women, boys, girls. Again, categories. So I make a two-way table. Can't make a scatter plot. Now, typically, your row variable is your response variable, and in this case, yes. And typically, the column variable is the explanatory variable. Now, something to watch for when we make a two-way table, a lot of times we like to use percentages in here and realize once I start dividing things out, making percentages, oftentimes I have to round things off to the nearest percent or tenth of a percent or whatever. At some point, I round it. And when I do that, there is, of course, round off that's happened. So maybe if I add up all the percentages, it doesn't equal exactly 100 because of rounding. That's okay. It shouldn't equal 80% when I find the total, but 99.9 or 100.1%, that can happen. Don't freak out. And also sometimes the problem will give you the percentage and you'll go, okay, so it's 50% of 101 subjects. And you go, wait a minute, that can't be. I can't have a partial subject. And that's okay. Again, it's round off. Things happen. You just chalk that up to it was rounding. All right. Now, if I want to make a graph from my two-way table, the appropriate graph would be a bar graph. Because again, scatter plot doesn't make sense. Histogram also doesn't make sense because these are categories. They are not quantitative. Now, of course, there's multiple types of bar graphs. So you could do a bar graph that's segmented, or there's lots of types. Also, I'm going to throw this one in, a mosaic plot. You'll want to look that one up. I bet if you Google Titanic mortality mosaic plot, you'll find one, and then you'll see exactly what I'm talking about. I don't have an example here in the PowerPoint, so that's a little extra work you can do on your own. Google Titanic mortality mosaic plot and find one, and then you'll see how it works. Okay. Now, once I have my two-way table, there's a lot of different questions that we could ask. These are the three general types of probability questions you might be asked. And I know Chapter 4 the topic isn't probability, but it's a good time to introduce this. Chapter 6, our topic will be probability, so we'll be doing all of these things. But since we have a two-way table, it's a good time to talk about the vocabulary. So the first type of probability is what we call a joint probability. So that's when we take a single cell and we divide it by the table total. So in other words, I could ask a question like, if I randomly select a passenger from the Titanic, what's the probability I got a girl that survived? So I would say, okay, well, that's 27 out of 2,223. That's what we call a joint probability. Because girl and survived, right? They're joining. They're both I've given you one column and one row that I have to hit both, and then it has to be out of the grand total. Okay, the next type of probability is what we call a marginal probability. The totals, we say they're in the margins. So the marginal probability uses a row or column total divided by the table total. So I might say, if I randomly select a passenger from the Titanic, what's the probability I get a girl? Any girl. So see, I would take the total of the girls and divide it by the table total. That would be marginal. Okay, the last type of probability is what we call a conditional probability. And that's when we take a single cell and we divide it by a row or column total. So I might say, if I select a girl from the Titanic's passenger list, what's the chances that she survived? So now I said I'm selecting a girl. So the 45 becomes, I have to be out of this column right here. I'm not dividing by the table total. I'm dividing by this column total. Okay, that's the condition. The condition is if I select a girl. So that's why we call it conditional. Okay, so those are the three types of probabilities that we'll see when we deal with two-way tables. All right, let's practice one of each. So take a look. If a passenger is randomly selected from the manifest, what's the probability of getting a woman that survived? Okay, so woman survived is 318, and we're choosing from the manifest, so from all the passengers. So 318 out of 2,223, and there you go. That's what we called a joint probability. Get that off. Okay, next question. If a passenger is randomly selected from the manifest, what's the probability of getting a woman? Okay, so any woman. So that's this entire column. So that's a marginal, right? The total is in the margin. So 422 out of, again, 2223 because it's from the manifest. Okay, that was marginal. Next, if a woman is selected, guaranteed I'm in this column. So now my denominator is out of 422 because I know I've selected from this column. What's the probability she survived? So that'd be 318 out of 422. And there you go. Okay, while we're here, I just wanted to point out some questions that students will struggle with sometimes. If you are asked to analyze this two-way table, how would you do it? What would you be comparing? So pause the video and think about that for a moment. If you were asked to analyze this two-way table, how do you compare the different variables? Okay. Let me give you some answers. Some people might say, looks like if you were a man, you had the best chance of survival, right? Because more men survive than any other category. Okay. But hopefully you see that there's a problem with that, right? More men died than any of the other categories as well because there were more men on the ship than any of the other categories. So, real important, when I'm seeing different totals, which is quite common, when I see different totals across my categories, I can't just look at the raw count. That's what I mentioned earlier. I have to think about percentages. So what I'd want to do is say, if you were a man, what's the chances you survived? If you are a woman, what's the chances of survival? If you are a boy, what's your chances? If you are a girl, what's your chances? So let's do that real quick. Okay, so if you were a man, about a 19.6% chance of surviving. Okay, if you're a woman, about a 75.4% chance of survival. if you were a boy, 45.3. And if you were a girl, 60%. And let's just do the overall survival rate. .8, roughly. Again, notice I had to round these off, so that's what I was talking about. There's some round off happening. So this is how I could compare. Again, my column variables were the explanatory variables, so I wanted to divide, and now I can compare those column variables, and hopefully you see that there is a relationship here, right? Again, it doesn't make sense to talk about correlation in this because it's categorical, but there is a relationship. If you were a woman, you had a much higher percent chance of surviving than if you were a man. Okay, and again, boys and girls also much higher chance of surviving than men on the Titanic. Was chivalry being practiced on the Titanic? It looks like it was to a reasonable extent, because these percentages are not very close together. When we get to do things like chi-square in second semester, you will actually examine if these could have happened by random chance or if there's more to it than that. And these clearly didn't happen by random chance. There's definitely a relationship between survival rate and gender. Okay, moving on. Let's try a quick problem here. I have some data comparing two airlines, and the question is very simple: which airline's more punctual, or in other words, on time? And again, realize we have different totals happening here, right? I can't just say, oh, America West is more punctual because they had more on-time flights, right? I could say America West has more delayed flights, so they're less punctual, right? I can't just look at the total, at the raw count, okay? I have to get the totals and then get percentages. So let's do that real quick. Okay, so I've now filled in the totals, the margins, right? And please realize that's not a variable, right? This was a 2x2 table. When I add the margins, it's still a 2x2 table. Those are just the totals. All right, so how do I answer this question, which airline is more punctual? Should I divide by column or by row? Right? Notice if I divide by column, I'm saying of the on-time flights, right? Which of these airlines has a larger proportion? But notice America West has so many more flights that that's not a fair comparison, right? Just like I said with the delayed flights, America West has many more because, again, they had many more total flights. So in this case, I need to be dividing by row. So I want to know, of the Alaska flights, what's their percentage of being on time? So let's do that real quick. So they're 86.7% on time. All right, let's check for America West. And they're 89.1% on time. So that's a fair comparison, right? 89.1% of America West flights are on time. 86.7% of Alaska flights are on time. So which airline's more punctual? Appears that America West is more punctual, right? All right, but there's more to this problem. Because let's pretend you are the CEO of one of these companies. And you want to look at your different flight crews. You say, oh, America West, we're more punctual, great. Maybe the Alaska CEO wants to go, okay, so where are my flight crews being outperformed? Where do they need more training? Where do I need to get them, more support or newer, better materials? So let's break this same data down by airport. Okay, notice these are the same totals, right? 3274 and 501, right? And for America West, 6438 and 787. So same totals, but now it's broken down by airport. So let's compare the two airlines by airport now, and that way we could say where is the Alaska Airlines in need of the most assistance and training. So let's go. Alaska, LA. Okay, 88.9. Okay, Alaska for Phoenix. $94.8. Okay, San Diego. My lovely dogs again. Let's see, 91.4. San Fran. 83.1. Seattle. 85.8. And again, the overall we had already calculated is 86.7%. All right, so there's Alaska by airport. Let's now do America West by airport. So LA, 85.6. Phoenix, 92.1. San Diego, 85.5. San Fran, 71.3. And Seattle, 76.7, with an overall of 89.1%. All right, so let's compare by airport now. All right, out of LA, looks like Alaska's actually doing a better job than America West. So if I'm the Alaska CEO, I'm gonna say good job, crew in LA, keep it up, you're doing good work. All right, out of Phoenix, same thing, Alaska wins. Out of San Diego, same thing, Alaska wins. Out of San Francisco, Alaska wins by a landslide. And out of Seattle, again, Alaska wins by a lot. So what's going on here? We said America West is more punctual, 89% on time versus Alaska, roughly 87%. Yet every single airport, Alaska is more punctual. How can that be? Okay, so pause it, think about it. Hopefully you see why. It's basically a simple algebra question. It's a question of weighted averages. You can see that the vast majority of America West data is coming from the Phoenix Airport, where they both do quite well, which is pulling the America West average up. The majority of Alaska's data is coming from the Seattle Airport, where they both don't do as well, which pulls the Alaska overall average down. So it's a weighted average thing. So somehow Alaska wins at every single airport, but because the majority of their data is coming from Seattle, they lose the overall race. Okay. When this happens, it's called Simpson's paradox. It doesn't happen that often. It's fairly rare, but it's very interesting when it does. And here's a great question. What's the lurking variable here? Why do both airlines do so well at Phoenix and they both do pretty poorly in San Fran and Seattle? Yeah, it's the weather. America West. They're flying a lot in the Southwest, or were. I don't know if they're still in business. But yeah, they flew a lot of flights in the Southwest. So the majority of their data is here. Phoenix, LA, high on time. Alaska Airlines, well, they're flying a lot of flights up there in the Northwest, flying to and from Alaska out of places like Seattle and San Fran. So they're fighting weather, and they're going to have a lot more weather-related delays if we only look at the overall number of flights. And so that's why sometimes it's very important to look beyond just the overall total number of flights and break it down and take into account lurking variables like weather. Okay, so there it is. There's the official definition of Simpson's paradox. It's the reversal of the direction of a comparison when data from several groups are combined to form a single group. So back here, right? Alaska wins in every group, but once I combine, all of a sudden America West wins. Okay, and again, the only way it happens is due to weighted averages. If both airlines flew the same number of flights out of every airport, this couldn't happen. But because there's a discrepancy in the weighting of the data, that's what allows it to occur. Okay? All right, so that's the lesson. Please look up mosaic plots on your own and just understand how to read them. I'm not going to have you make a mosaic plot because it can be a little bit tedious with all the different categories, but understand how to read a mosaic plot.